So for a problem like this, how do we approach it? This is actually a common deal that was offered by a popular chain restaurant for years. A large, which is a 16-inch diameter, is $16. Or you can get two mediums for $19. I can remember actually arguing with a waiter once because he kept saying, well, that's 24 inches of pizza for only $3 more instead of 16 inches. Just couldn't get it through his head. So what is this? Well, the 16-inch pizza. It's not the 16 inches that we're concerned with. What are we concerned with? We want the radius, which would be how much? 8 inches. So that makes the area of that one pi times 8 squared, which is 200.96 square inches. Yes? So now then the 12-inch pizza has a radius of 6 inches. So that will have an area of pi times 6 squared, otherwise known as what? 113.04 square inches. But, as the waiter so energetically points out, you get two of them. So it's 226.08 square inches. So it is more pizza over 25 square inches more pizza. But how do we know if it's a good deal? Well, you need to come up with a rate of somewhere, and the rate is usually dollars per square inch. So for the 16-inch pizza, which is $16, divided by 200.96 square inches, you get 0.0796. Or 7.96 cents per square inch. On the other side, that was $19 over 226.08 square inches. Gives us 0.0840 per square inch, or 8.40 cents per square inch. Which one's cheaper? The 16 inch is still cheaper. Is that similar to the one in the homework you were asking about? So it's always, if it's dollars per square inch, it's dollars divided by square inches. You can use the units to kind of tell you what to. Okay, well, to tie some things together now, but from the first part of class here. Let's say I have a rectangle that is 3 by 10. And I am going to enlarge that rectangle. So this is now 9. What's this side going to be? Well, the ratio is 3 to 9, right? Where's the 10 go? On top. So my missing sides on bottom, 9 times 10 divided by 3 gives me 30. This has to be 30 units long. What's the area of this one? Well, 3 times 10, right? Length times width is 30 units squared, whatever those units are. Now, if I look at the sides, the side was multiplied by 3. 3 times 3 makes 9. 10 times 3 makes 30, right? So should the area be multiplied by 3? Should this be 90 units here? Say no. Good. What is the area here? It's 9 by 30 is 270. That's a drastically different area. So let's look at our ratio of lengths here. Our ratio of lengths was 3 to 9, which reduces to 1/3. Our ratio of areas is 30 to 270. Both of those can divide by 30 is a 1 to 9 ratio. Not the same, is it? Well, let's keep that in mind and let's look at another example. So here's a right triangle where this is 2 and this is 6. And I'm going to enlarge it so that this is 8 and this is 24. What is the ratio of lengths? Well, give me two sides that correspond. 2 goes to what? 8. So that's a 1 to 4 ratio of lengths. What's the area of this one? 2 times 6 divided by 2, because it is a triangle, is 6. What's the area of this one? 8 times 24 divided by 2 is 96. So my ratio of areas is 6 to 96, which reduces to a 1 in 16 ratio. Can you see a relationship between the ratio of lengths and the ratio of areas that holds true for both of these problems? Okay, yeah, multiplying by itself. And the shortcut in math for that is just squared. And it's not just the denominator. It works out this way that it's the denominator, but the 1 is squared as well. So if that numerator was something other than 1, you would square that too. The ratio of areas in a figure is the square of the ratio of lengths. Why is that useful information to us? Well, because these two figures that I did right triangles and I did rectangles. It's really easy just to calculate the areas. But what if we have something funny like this? Well, every now and then in the real world you run into some weird shapes. I'm not saying necessarily that one, but let's say that's 4 inches and you know its area is 576 inches squared. And over here you've enlarged this to be 6 inches. How do you find that area? Well, what is my ratio of lengths? 4 to 6. Now, before I do anything with that, I'm going to reduce that. 4 to 6 can be reduced to what? 2 to 3. Yeah. For my ratio of areas, I'm going to take that 2/3 and do what to it? square it. Yep, I'm going to square it. So what's 2 squared? 4. What's 3 squared? 9. So my ratio of areas has to be 4 to 9. Now I have the 576. Does that go on top or bottom? It's from the smaller one, so it goes on top of the smaller one. And then I can cross multiply and divide. 9 times 576 divided by 4 is 1,296. Or 96 square inches. What do you think? Good stuff? Not too horrible? Well, good. I don't know. I personally prefer cheat. The hard part isn't drawing the first one, it's drawing the second one to be proportional. Find the area of the second one. Great timing to yawn just to turn the recording back on, huh? What's my ratio of lengths? 2 to 5. Can't reduce that, so we're going to live with it. So now for my ratio of areas, I take that 2 to 5, and what do I do to it? I square it. So what do I get? 4 over 25. Good. 2 squared is 4, and 5 squared is 25. What goes in the next one? 400 goes on top. We cross multiply. 25 times 400 divided by 4 is 2,500. How many of you got 2,500 square inches for the area? Sure. Okay, enough celebrating. So anyway, next up. Let's say I take a box, and I'm going to enlarge my box. So for this, what is my ratio of lengths? Yeah, it's 12 inches. Can I rewrite it? So what's my ratio of lengths? That's it. 3 goes to 9, or 5 goes to 15, or 4 goes to 12, either way. 3 goes to 9, which reduces to a 1 to 3. Now, if I wanted to compare volume, what do you think I'm going to do to that 1 to 3 ratio? Cube it. Very good. For volume, now there's 3 dimensions that are changing. It is cubed. What's 1 cubed? 1. What's 3 cubed? 27. Yeah, there you go. 27. So now what goes over here? Well, I don't know the volume of one of them yet. This volume over here, 3 times 5 times 4, is going to be 60 cubic inches. So I'm going to put that on top. If I were to cross multiply and divide here, I get 1,620, I believe. Is that the correct volume over here? Yes, it is. Now again, with simple boxes, I wouldn't go through this ratio. I'd just find the volume. It's really easy to do. But you might have something like this. Where I have an object that has been enlarged. The height of this object is 4 inches. It has been enlarged to 10 inches. The surface area of this first one is 800 square inches. Find the surface area of this one. So I have my ratio of lengths, right? What's my ratio of lengths? 4 to 10, otherwise reduced to 2/5, right? Surface area. What am I going to do to that 2/5? What's the key word in surface area? Area. That indicates squared. 2 squared is 4. 5 squared is 25. So I'm going to use the 4 over 25 along with the 800. Cross multiply and divide to get, what is that, 5,000? This is my surface area. The key is it's inches squared, which means you're going to be squaring the relationship. What most of you were expecting me to do is something like this. So the volume is 1,200 cubic inches. So now over here, the ratio of volumes is going to be, what am I going to do to my 2 to 5 now? Now I'm going to cube it. 2 cubed is 8. 2 times 2 times 2. 5 cubed is 125. Oh, I might want to put a 3 there for cube. Thank you. Cube. There we go. So it's 8 to 125 is our ratio of volumes. Now I have 1,200 here. I will cross multiply and divide. Yes, 18,750. So the volume here is 18,750 inches cubed. How do I know whether I'm going to square this factor, the lengths, or cube the lengths? Well, one, it's the units on the power on my units, if it's square inches or cubic inches or square feet or cubic feet. Also, area is always square, volume is always cubed. Any questions? Well done. this has gone from 20 feet up to 60 feet. This has a surface area over here of 720 square feet and a volume of 1,350 cubic feet. So over here, find the surface area and the volume. Try that in your note. Okay, so let's start out. What's our ratio of lengths? 20 over 60, which will reduce to what? 1 to 3. Good. For my areas, which is going to apply to my surface areas as well, what am I going to do that 1/3? I'm going to square it to give me what? 1 over 9. What goes in the next one? 720 goes on top. We cross multiply and divide. 9 times 720 divided by 1 is what? 6480 square feet. How many of you had 6480? Good deal. For the volume, we go back to our ratio of length of 1/3. What do we do with it? Cube it. So what do we get? 1 over 27, perfect. And then what do we put over here? 1350. And then cross multiply and divide, and we get what? 36,450. Very good. That is cubic feet. How many of you got that? Good deal. Okay, so that part seems to be catching on fairly well. Good. Now, I am going to end this recording here quick, and then we'll just start a new one right away, just because the topic is a big enough change of pace that I don't want to have the two of them